In this video, we are going to discuss question 18a and b, where we calculate current in the circuit. So here you have a circuit with two batteries and resistors, and you need to calculate the total current in the circuit. I'm going to use Kirchhoff loop rule to solve this, but you can use basic understanding of Ohm's law to solve it as well. In order to use Kirchhoff loop rule, I'm going to first show the direction of current. You can choose the flow of current in any direction. I generally prefer it coming out of the bigger cell. So 12 volt is the bigger battery over here. So I will take my current coming out of the positive of 12 volt battery. So this is the direction in which current is flowing, which is clockwise. We call it I. Then we choose the direction of traversing. Direction of traversing, again, you can choose it to be either clockwise or counterclockwise. I will choose it to be clockwise in the same direction as current. You can label the resistors and the battery. We can call this V1, V2. This will be small r1, r2. Small r because these are internal resistance of the battery. And this can be capital R1, R2 because they are external resistor. According to Kirchhoff loop rule, sum of potential difference around the loop is equal to 0. So when I'm moving around the circuit, I will be traversing in the direction going from A, B, C, D, and then back to A. So when I go from A to B, I see resistor R1, and I'm moving in the same direction as the current here. So whenever you move in the same direction as current for a resistor, the voltage drop across the resistor will be negative. So I take it negative I times R1. Voltage across resistor is taken as I times R. Then I am entering negative terminal of the battery. Whenever you enter the negative terminal of battery, you take the voltage drop across the battery to be positive. Then I move on and enter positive terminal of the second battery. So in this situation, this will become negative. Then for R2, we are again going in the same direction as current. So voltage drop across R2 will be negative. So minus I times R2. Then moving on, you come to resistor R2. And again, we are going in the same direction as current. So it will be minus I times R2. And then same for R1, minus I times R1. And this is equal to 0. So let's move all the terms with I to one side and all the terms with VEMF to the other. So V1 minus V2 will be equal to, since I is common in all of these terms, I'm going to take it outside. All of them are minus here. When they go to the other side, they will become plus. So I times R1 plus R2 plus capital R1 plus capital R2. We need to find current, so just divide with this. You can substitute the values and then divide. So V1 is 12, V2 is 6, I is missing, R1 is 0.3 plus 0.2 plus 1.5 plus 1. So that gives you 6 equals I times 3, or I equals 6 over 3, which is 2 ampere. Then we do the same thing in the next problem. I'm going to use Kirchhoff loop rule again to calculate the current in the circuit. So let us start with showing direction of current. I will take the current coming out of the bigger battery from its positive terminal. So now this is the direction of current, counterclockwise. We call it I. Then we choose direction of traversing. Direction of traversing, I'm going to take in the same direction as the current, again counterclockwise. You can label the loop A, B, C, D, and then label the components. This will be V1, V2, small r1, small r2, and this is just capital R. I'm going to go counterclockwise starting from A. So we go to loop A, B, C, D, and back to A. Now when you go from A to B, you're moving in the same direction as current. So voltage drop across the resistor will be negative. So minus I times R. Then when you go from B to C, you enter positive terminal of the battery. If you enter positive terminal, voltage drop of the battery will become negative. Then we move in the same direction as current in R2. So it will be minus I times R2. Same with R1. When I come to R1, I'm going in the same direction as current. So minus I times R1. Then we enter negative terminal of the battery. If you enter the negative terminal, that voltage will be positive. This is equal to 0. Now again, move all the terms with I to the other side. And since they are all negative, when they move to the other side, it will become positive. So here you are left with V1 minus V2 equals I times R1 plus R2 plus capital R. Now substitute V1 is 2, V2 is 1.6 equals I times small r1 is 2, r2 is 1.2 and capital R is 0.8. That gives me 0.4 equals I times 4, or I equals 0.4 over 4, that will be 0.1 ampere. So this is how you can use Kirchhoff loop rule to calculate current through any circuit.